Hello students, my name is Akshita Shetty and I am going to teach business mathematics. This is the syllabus for first year BCom students second semester as per NEP syllabus. And now you can see the syllabus. Many books are available from United Agencies, Kalyani Publication, Vision Book House. So I cannot comment which one is better, but I would be referring to United Agencies. Okay. So in the class I am using Kalyani Publication and Vision Book House. So I'll be referring to three books at a time. In the YouTube videos, I'm referring to United Agencies. Okay. So let's start with Unit 1, which is number system and indices. So the part 1 is number system. So let's start with number system. Okay. So if this is a number line, 0, 1, 2, 3, 4, so on till infinity, -1, -2, -3, -4, so on till -infinity. Okay. Now we are doing part 1, which is number system. Okay. So the counting numbers 1, 2, 3, 4, 5, 6, 7, 8 and so on till infinity are called natural numbers. Oops, sorry. These are called as natural numbers. They are also called as positive integers. Natural numbers are denoted by capital letter N. So 1 to infinity are natural numbers denoted by capital letter N. And if you add 0 to natural number, it will become whole numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8 till infinity is called as whole numbers, which is denoted by capital letter W. So all natural number together with 0 are called whole numbers, which is denoted by capital letter W. The whole set, which is negative numbers, -1, -2, -3, -4 till infinity, 0, and positive numbers 1, 2, 3, 4, 1, 2, 3, 4 till infinity are called as integers, which are denoted by capital letter Z. So the set of all positive numbers and negative numbers together with 0 is called the set of integers, which is denoted by Z. Okay. So 1, 2, 3, 4, 5, 6 till infinity are called positive integers. -1 till infinity, -1, -2, -3, -4 till infinity are called as negative integers. And 0 is also a integer which is neither positive nor negative. Okay. So even numbers. What are even numbers? Numbers which are divisible by 0 are called as even numbers. Sorry, the numbers which are divisible by 2 are called as even numbers. So 0, 2, 4, 6, 8, 10, so on are called as even numbers, right? Even -2, -4, -6, -8, -10, minus 12 and so on, they are also even numbers. Okay. So when it comes to even numbers, nth even number is 2n. Okay, what do I mean by saying this is, now which is the third even number? Third even number. So third even number will be 3 into 2. Okay, because n is 3 multiplied by 2. So third even number is 6. 10th even number will be 2 multiplied by 10, which is 20. Okay. 66 is 33rd even number, and 128 is 64th even number. Got it? Okay. So any number which is divisible by 2 is called as even number. What are odd numbers? Odd numbers are those numbers which are not divisible by 2. For example, 1, 3, 5, 7 and so on are odd numbers. The numbers which are not divisible by 2 are called as odd number. So nth odd number will be 2n minus 1. Okay, so 2 multiplied by n minus 1. Now which one is 10th odd number? 2n minus 1. 2n means 2 into 10. Okay, minus 1. 2 into 10 is 20. 20 minus 1 is 19. So 10th odd number is 19. Similarly, 66th odd number will be 62 into 66 minus 1. Okay, 2 into 66 is 132, right, minus 1, which is 131. Okay, all right. So okay, now we know what are natural numbers. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8 till infinity. Whole numbers are, the natural numbers plus 0 are called as whole numbers. Negative number, positive number and 0 together are called as integers. Right? Even numbers are 0, 2, 4, 6, 8, 10 and so on. Even negative even numbers are called as even numbers, minus 2, minus 4, minus 6, minus 8 and so on. The numbers which are divisible by 2 are called even numbers. The numbers which are not divisible by 2 are called as odd numbers. Next one is prime numbers. What are prime numbers? The numbers which are divisible by itself and 1 are called as prime numbers. The numbers which are only divisible by itself and 1 are called as prime number. Okay. For example, 2, 3, 5, 7, 11, 13, 17. It is divisible only by itself and 1. That's it. So they are called as prime numbers. Okay. Plus and minus 1 and 0 are not considered as prime numbers. Okay. Next one, composite numbers. Composite numbers, the numbers which are not prime numbers are called composite numbers. For example, 4, 6, 8, 9, 10, 12, 14, 15, 16 and so on. These are composite numbers because they are divisible by any other number. For example, 24, 4 is divisible by 2, 2 2s are 4, right? So 4 is a composite number. Now 6 is 3 2s are 6, so again it is divisible, right? 6 is divisible by 3, 3 2s are 6, and it is also divisible by 6 is also divisible by 2. 6 2s are 2 3s are 6, right? And 8 is divisible by 2, it is divisible by 4, right? So 4 2s are 8 or 2 4s are 8, so 8 is also divisible, right? 9 is divisible by 3, 3 3s are 9. 10 is divisible by 5 and 2, 5 into 2 is 10. 12 is divisible by 6, it is divisible by 3, it is divisible by 2, right? So composite numbers are those numbers which are divisible, okay, by other numbers. But when it comes to prime number, it is divisible only by itself. So 2 is divisible only by 2. 2 1s are 2, right? So it is divisible by itself or it is divisible by 1, right? So 1 2s are 2. So here 2 is divisible by 1 and itself. That's it. No other number. It is not divisible by any other number. So that's why 2 is a prime number. Even 3 is divisible by 3 and 1 only. Okay. So it is a prime number. 5 is divisible by 5 and 1. That's it. It's not divisible by any other number. So prime numbers are those numbers which are divisible by 1 and itself only. They are called as prime numbers. Composite numbers are those numbers which are not a prime number. Okay. When it comes to plus and minus 1 and 0, they are neither prime number nor composite numbers. Okay. Next is rational number. Rational numbers. What are rational numbers? The number which can be expressed in the form of P by Q are called as rational numbers. So numbers which can be expressed in the form of P by Q are called as rational numbers, where P is the integer or numerator and Q is the denominator. Q should not be equal to 0. It cannot be equal to 0. Okay. So example, 1 by 2 is a rational number, 7 by 3 is a rational number, minus 9 by 2 is a rational number, 5 is a rational number because 5 we can write it 5 by 1, right? So if any number you can write in the form of P by Q, then it is called as rational number. Now 7 by 5, okay, is a rational number. Correct? Okay. Rational numbers are denoted by the capital letter Q. So set of all rational numbers denoted by Q. Okay. Now, is 1.6 a rational number? Yes, it is a rational number, because 1.6 can be written as 16 by 10. Right? Okay, how I came to this? Okay, 1.6 is 1.6 divided by 1, right? Okay, multiply both the numerator and denominator by 10. So this becomes 16 by 10. So 1 by 6 can be written as 16 by 10. So 1 by 6 is also a rational number. Okay? So any number which is recurring and terminating, for example, now 0.54545 and so on. So what is happening? 54 is recurring. So 0.54 is recurring, right? So this is a rational number. So any number which is recurring, it is a rational number because it can be written in this form. We can write it in P by Q form. We can write it in P by Q form. So any number which is recurring, it can be written as P by Q form, or any number which is terminating. For example, 1.25, it is terminating because the decimal is getting over, right? So it's only 1.25, that's it. Okay? So, or 0.32, 0.568. Okay? So this is a terminating number. So decimal, so any terminating or decimal decimal, okay, so these are terminating decimals. It is getting its ending. Okay, so these are called as rational number because the numbers which are recurring and numbers which are terminating can be written in P by Q form. Okay, so I will be teaching you all that as well, how to convert recurring decimal or terminating decimal into P by Q form. Okay. Okay. Now, so any number which is terminating and which is recurring can be written in P by Q form. Therefore, all these numbers are rational number. Okay. Now, what cannot be written in P by Q form are called as irrational number. For example, 6.5239876345, it's neither terminating, it is neither recurring, right? And so on. So this is a irrational number. So numbers which are not terminating and not recurring are called as irrational number because they cannot be converted into P by Q form. So a number which can be converted into P by Q form where Q is not equal to 0 is called as rational number. The number which cannot be written in P by Q form are called as irrational number. So rational number are either recurring decimals or terminating decimals. Irrational numbers are neither terminating nor recurring. Okay. Let us express the following decimals as rational numbers. Okay. So I'll give you one example. Okay. So the first one is 0.555. It is ending here. Is it a rational number? Let's see whether we can write it in P by Q form. So this can be written as 0.555 divided by 1. You multiply the numerator and denominator by 1000 because there are 3 decimals. So 3 zeros. Okay. So this can be written as 555 divided by 1000. So 0.555 can be written as 555 divided by 555 divided by 1000. Therefore, it is a rational number. So this is a rational number. Okay. Now next one. Next example. 0.32. 0.32 can be written as 32 by 100. Take a calculator and do 32 by 100. You will get the answer 0.32. So it is a rational number. Okay. Now let us take one more example. 1.32 recurring. When I say 1.32 recurring, I mean it is 1.323232323232. Correct? It's never ending, but it is recurring. 32 is recurring. Whether this is a rational number or not. Let's see whether I can write it in P by Q form. Okay. So, okay. Let x is equal to 1.32323232 and so on. Okay. So if this is x, okay, and I'll name it as number 1. Okay. So x is equal to 1.32323232 and so on. I'll multiply both the sides by 100. So first equation, okay, I named it number 1, right? So number 1 multiplied by 100, because there are two numbers are decimals. Two decimal numbers are recurring. It is 1.32 decimal. That two numbers after decimal which is recurring. So that's why I'm multiplying it by 100. Okay. So if I multiply equation 1 by 100, it will become 100x is equal to, I multiply this by 100, I'll get 132.32323232, right? And let this be number 2. Okay. So what is happening? My decimal is same. I'm making sure my decimal is same. Okay. So now I will do 2 minus 1. That means 100x minus x. When I do 100x minus x, I get 100x minus x is 99x, and 132.32323232 minus 1.32323232 is 131. Correct? Okay. 132.323232 and so on minus 1.323232. So my decimals are same. So 0.323232 minus 0.323232 will become 0. And 132 minus 1 is 131. So, oops. Making a lot of mistakes today. Correct? So I can say 99x is equal to 131. So x is equal to 131 divided by 99. So I can write this. In the form of P by Q. Correct? Okay. Okay. Now, next one. One more example. So x is my this number, right? Let x be 1.32323232, and now x is equal to 131 by 99. So 131 by 99 is 1.32 recurring. If you want to check, you can just use a calculator. Where's my calculator? Okay, so I got 1.32 recurring is equal to 131 by 99. Let's check it. 131 divided by 99. So it is 1.3232323232. Correct? So that means 1.32 recurring is equal to 131 divided by 99. Okay. Now I'll solve one more example. Suppose 0.333333 and so on. Okay. Now 0.33333 I can write it as 0.3 recurring, right? So let x is equal to 0.3 recurring. Okay. So let this be 1. Because only one number is recurring, I'll multiply by 10. So 1 multiplied by 10. Okay, so it will become 10x is equal to 3.3 recurring, right? So when 0.3 recurring means 0.33333333 so on. When you multiply by 10, 10 has 1 0, so the decimal will shift from here to here. So it becomes 3.33333333. Correct? So 3.33333 is 3.3 recurring. Correct? I'll use a calculator and show it to you. Okay? 3.3333, no, it was 0.3 recurring, right? 0.333333, it's recurring. Correct? Multiplied by 10, I will get 3.333333. Okay, so when I multiply by 10, I get this. Okay, now this, let this be my 2. Now I will do 2 minus 1. So 10x minus x is 9x, right? And 3.3 recurring minus 0.3 recurring will be 3. So x is equal to 3 by 9, which is 1 by 3. So x is equal to 1 by 3. So 0.33333333 can be written as 1 by 3. Correct? If you want, you can just check. Okay? So see, 1 divided by 3 is equal to 0.3333 and so on. So that means when a number is a recurring number, or when a decimal number which is terminating decimal number, it can be written in P by Q form. Okay, so these are rational numbers. So if a decimal number which is neither recurring nor terminating, it cannot be converted into P by Q form. So it is a irrational number. Okay, so I'll show one more number, which is 5.915915 and so on. Okay, so here 915 is recurring, so it is 5.915 recurring, right? So yeah, let x is equal to 5.915, which I'll name it as number 1. 3 decimals are recurring, so I'll multiply it by 1000. So I'm multiplying the above x by 1000. Okay, so now it becomes 1000x is equal to 5. This decimal will shift here, correct, because I'm multiplying it by 1000, so it will become 5915.915, right? Okay, now let this be number 2. Okay, so 2 minus 1, so 1000 minus 1x, 1000x minus 1x is 999x, and the right hand side, okay, this minus this, so the decimal is same, right? So it will become 0. 5915 minus 5 will be 5910. So x is equal to 5910 divided by 999. So I can say that 5.915 recurring is equal to 5910 divided by 999. Okay. So a recurring decimal can be written in a P by Q form. Okay. So it is a rational number. Okay. Now when it comes to irrational number, so root 2 is a irrational number because it cannot be written in P by Q form, because root 2 is equal to, so root 2 is equal to 1.4142135623731, and the number keeps on going. Okay, so root 2, it is neither terminating, it is not recurring as well, it cannot be written in P by Q form, therefore it is a irrational number. Even root 3, root 5, all these are irrational numbers. Okay, so let's see. Root 5 is an irrational number. The decimal is neither terminating nor recurring. Okay, and even pi is an irrational number. Okay, pi is written as 22 by 7, but it is not a exact decimal, I mean exact number. Okay, because pi is equal to, now pi is 3.142857, and it's keep on going. Okay, you can say that pi is equal to 22 by 7, but this is not the exact number. Okay, so pi is also an irrational number. Okay. Okay, just note root of a prime number. Okay, so let p be a prime number. If you take a square root of p, a prime number, it is always an irrational number. So root of a prime number, square root of a prime number is an irrational number. So root 2 is an irrational number because 2 is a prime number. Root 3 is an irrational number because 3 is a prime number. Root 5 is an irrational number because 5 is a prime number. Root 4 is not a prime number, is not an irrational number. Why? Because root 2 is equal to 2 and 2 can be written as 2 by 1. So root 4 is not a irrational number, but root 2, root 3 and root 5 is a irrational number. Okay, so these are irrational numbers. And root 4 is a rational number. Okay, so if p is a prime number, then root p is a irrational number. Okay, okay. Now when it comes to 6, okay, so 6 is not a prime number, correct? But root 6, whether it is a rational number or irrational number, let's check. So 6, root 6. Even root 6 is an irrational number, see, because the number is neither terminating nor recurring. So root 6 is also irrational number. So it is not necessary if the number is a composite number, the root will not be a irrational number. It is not necessary. Okay, so but yes, if you are taking square root of a prime number, it is always an irrational number. Okay, so root 6 is also irrational number. Root 10 is also irrational number. Let's check that as well. Okay, so 10 square root. See, 16227766016838. Okay, so this is also neither terminating nor recurring. So root 10 is also irrational number. Okay, 10 is not a prime number. Still, root 10 is an irrational number. Okay. Now when it comes to root 9 is a rational number. Why? Because root 9 is 3 and 3 can be written as 3 by 1. So it can be written in p by q form. Therefore, it is a rational number. Okay. So we have studied all the types of numbers. Okay, one more. Real numbers. Real numbers. What are real numbers? Real numbers are rational number and irrational number together are called as real numbers. So real numbers are rational number plus irrational numbers. Okay, so rational numbers and irrational numbers together are called as real numbers. Okay, so let's revise what we did just now. Okay, so 1 2 3 4 5 6 7 till infinity are called as natural numbers. When you add 0 to natural numbers, it becomes whole numbers. So 0 1 2 3 4 5 6 till infinity are whole numbers. Okay, when we add negative numbers to whole numbers are called as integers. So 0 1 2 3 4 5 6 7 till infinity and -1 -2 -3 -4 till infinity are called as integers. So 1 2 3 4 5 6 and so on till infinity are called positive integers. -1 2 3 4 and so on, -1 -2 -3 -4 till minus infinity are called as negative integers, and 0 together. So negative integers Positive integers and 0 are called as integers. Even numbers are those numbers which are divisible by 2. Odd numbers are those numbers which are not divisible by 2. Prime numbers are those numbers which is divisible only by itself and 1. Okay. Composite numbers are those numbers which are divisible by other numbers, which can be divisible by some other number. Okay. So the numbers which are not prime numbers are composite numbers. Okay. So -1 and +1 are neither prime number nor composite. Okay. Okay. Rational number. Rational numbers are those numbers which can be written in the form of P by Q. So rational numbers are those numbers which can be written in the form of P by Q. A decimal number which is recurring are called as rational numbers because they also can be written in the form of P by Q. The numbers which are terminating, okay, for example 1.25, this is also a rational number because this can be written in the form of P by Q. So 1.25 can be written as 125 divided by 100. So this can be written in the form of P by Q, therefore this is also a rational number. Okay. So numbers, and I have given some examples as well. Numbers which cannot be written in the form of P by Q, for example √2, √3, √5, √6, √10 are irrational numbers. So the numbers which are neither terminating nor recurring are called as irrational numbers. The numbers which are not rational numbers are irrational numbers. Rational numbers and irrational numbers together are called as real numbers. In the next class, we will be solving few problems. Okay, that's it for the day, students. Have a great day. Thank you very much.